We are conducting a simple regression. This is Darlene Whitlock from California Intercontinental University in the Business Research and Methodology and Quantitative Stats course. In today's presentation, we will be explaining the hypothesis testing for regression. We will conduct 3 simple regression tests, then we'll talk about some takeaways and then questions. The hypothesis test that we will perform will state that the dependent variable in our first test is going to be debt, and our independent variable will be income. The regression hypothesis for the null statement says the slope of the regression is 0. Our alternative hypothesis will state the slope of the regression is not 0. Our rejection rule that we will follow is we reject the null when p-value is less than alpha, where alpha equals 0.05. Our confirmation rule is OE at 95% CL. What we are actually asking is whether there is a statistically significant estimate of a participant's debt using their income. And you'll see how this works in our first example. In our first example, there's been no significant result found. So we are testing debt in relation to income, and our following regression was conducted. The null hypothesis states that the regression coefficient, or income, is 0. The alternative hypothesis states that the regression coefficient for income is non-zero. A simple linear regression was conducted to determine whether debt could be predicted for income. No significant regression was found. Our beta is 0.05, r squared is 0, and our p-value is 0.535, which is greater than our alpha. In our second hypothesis test, we looked at savings and income. The following regression was conducted. The null hypothesis states the regression coefficient of income is 0. Our alternative hypothesis states the regression coefficient of income is non-zero. In this test, a simple linear regression was conducted to determine whether savings could be predicted from income. A statistically significant regression emerged. Our beta is 0.91. R squared is 0.82, and our p-value is 0. Thus, the test rejected the null hypothesis and predicted aggression passivity scores. Savings is predicted to decrease as income increases. Further, the 95% does not contain 0, hence lending support to our prediction. Our third hypothesis was between stocks and savings. The following regression was conducted. Our null hypothesis states the regression coefficient savings is 0. The alternative hypothesis states the regression coefficient savings is non-zero. A simple linear regression was conducted to determine whether stock scores could be predicted from savings. A statistically significant regression emerged. Our beta is 0.28. R squared 0.07, and our p-value is 0. Thus, the test rejected the null hypothesis. Stocks is predicted to decrease as savings increase. Further, the 95% does not contain 0, hence lending support to our prediction. For takeaways, you can rest assured that programs like PSPP can be used to compute linear regressions as well as other functions. So our mathematical questioning becomes simpler to determine our results. Performing our linear regressions allows a user to compare one variable to use one variable to predict another one. If you reject the null hypothesis, then the user should also check for the confidence interval, which should not contain R0, to support our prediction. Thank you for watching this presentation. If there are any questions, please leave them in the post below. Thank you.